So about 8 months ago, I got an email from Igor Stiligoy, who is not here in person, but I think is here in spirit. And he said, we should submit a paper to CHEP about something. And I've been here long enough to know what we means in this case. But, you know, I took the bait and I said, well, what do you think we should write about? And he said, well, we recently added this microarchitecture support to Condor, and I think that would be super useful. And I, you know, at first wasn't so sure. I thought, well, that's kind of a small thing. But he convinced me, well, this is really important. A lot of people don't know about it. And then I realized I could do my favorite thing, which is take some small subject that I kind of want to talk about and spin something bigger that I really want to talk about around it. And that's what this talk is come to. I really want to talk about naming and the power of naming here, which I think is a superpower, a personal superpower that we all could have if only we take the time to pay attention, have some discipline and some practice in better naming. I think the superpower also has a dual super weakness, which we all too often fall into when we don't pay careful attention to naming. So let's start. I think all of us here have some role in the OSPool, whether it's building it or operating it or using it or even knowing about it. So I'd like you to take this moment and maybe close your eyes for a second. And when you think about the OSPool, what do you think about? What vision do you have in your head? Do you have like a mental model or a mind map or some image of the OSPool? What is the OSPool when you think about it? You know, for some people, maybe the OSPool looks like this, a large community of people sharing resources, or maybe you're the kind of person who dreams in Python and has long hallway arguments about what Pythonic really means. You think about it like this. Maybe if you work with users, you think about the OSPool and OSG like this, but that's not the way I think of it. I think of the OSPool like this. It's a stone soup where different organizations, different communities donate their carrots and potatoes and GPUs and stones, and we all work together to make this magical alchemical elixir that we can all use to further science and other kinds of research, which makes all of us here, no matter what our role is, like the witches in Shakespeare's Scottish play. But that term witches, I think, has been stolen and mutated by, you know, the patriarchy of the dominant religion. So I would prefer that we're all called sorcerers. And there's an ancient truth about sorcerers, which is kind of at the heart of this talk. And that is, a sorcerer only has power over an object. The only time a sorcerer has power is when they can speak the true name of that object. And unfortunately, I think like many of our deepest truths, this is not to be found in a computer science textbook or a math textbook, or thank God Frank's not here, even a physics textbook. But it's really woven into the DNA of our human experience. Speak, friend, and enter. This goes all the way back to Homer, whose hero, the wily Odysseus, refused to speak his name to his captor, the carnivorous Polyphemus, and in doing so assured his escape. And this isn't even a Western idea either. Even Confucius knew about the power of names. Nor is this an ancient only thing. Even in times closer to us, in places closer to us, people talk about this and the power of names. But I don't want you to think that I'm being flippant or hyperbolizing here. I really believe that names have power. Sometime during this workshop, I guarantee you, at least two people have had a conversation where one has complained about some aspect of jobs to another person in this room, or maybe on the Zoom call. And the second person was a little lost. There was some additional friction because they didn't really understand what the speaker was saying when they said jobs, because we overload this term so much. Did they mean the science job that's actually doing the work? Do they mean the glide-in job, which we call a job and sort of treat as a job, even though it doesn't have a job nature? Maybe they mean what Cole calls the Dagman proper job, it's kind of a different thing. Or maybe it's going through a CE, in which case it's the A side of the CE or the B side, or maybe both. And because of this lack of clarity, there's additional friction and difficulty in communication. And this term job also shows something else. It's a perfectly good term in some contexts, but not in the very specific context. So the power of a good name is often textual. But that's not the only power of naming. I believe a stronger power of naming is the power of metaphor. A big change we made to DAGman in this last thing that Todd did not talk about in his talk of flies was we made a significant performance enhancement to DAGman, where DAGman has the ability to have associate priorities with the nodes in the DAG. And unfortunately, we had a little n-squared algorithm in DAGman, such that if you had more than about 1,000 nodes with distinct priorities, it wouldn't just get slow, it would crawl to a halt because of this n-squared problem. And there's a well-known solution to this. We used a heap data structure, which is a horrible name, because every time you say, I'm going to use the heap data structure as a computer scientist, you have to say, oh, I mean the heap algorithm, not the dynamically memory allocated heap, because this name is so overloaded and so poorly named. Indeed, what do you think the operations on a heap are if you're not a computer scientist? Who knows? It's a horrible name. But recently, I was doing my 5-year reread of the best computer science book ever written, The Structure and Interpretation of Computer Programs. And I realized on my 4th read through over 20 years that they implement this same heap data structure, but they give it a different name. They call it an agenda. An agenda. I think this is a great name because even if you're not a computer scientist, even if you don't know what a heap is, I bet you, you could guess what an agenda does, what the operations on an agenda are. Skip the first 3 because we don't want to talk about them in these meetings. That's our kind of agenda. And this name gives us power. And I believe that one of the reasons we didn't use a heap in DAGman initially is because the term heap is so awful. If the term agenda had been raised to common use, maybe we would have used it from the beginning because it would be in our heads and we wouldn't have skipped over that. But I think the most powerful form of good naming is the power of generation. So we don't have this feature yet in Conner, but we've talked about it. That is a class add passport visa. So when a job goes from place to place, like a visa stamp, it could have a stamp of the places, the sites, the machines that it's been on. And even if I don't tell you anything else about this feature, but if I just call it a class add passport visa, I bet you can guess not only what it does, but what it should do as well. And I would call this the power of generative naming. And I think these 3 things really show how a good name gives us power. And we should be very careful when we choose names to utilize that power. Now, of course, the best time to say to plant a tree is 20 years ago, and the second best time to plant a tree is today. And we haven't been very good at naming in the past, and so we've been trying to work towards improve our naming. So we've renamed the submit point, the access point, the compute element, the compute entryway. And I know this has been difficult, and some people a little controversial to some people in this room, maybe everyone in this room. But I think this is really a good idea, and it's worth the pain in the short run to have these better names and to get these clarity and metaphorical and generative powers in the future. Now, sort of bring it back down to the stratosphere here. Let's talk about how this affects the OSPool. Intel processors have these names: i3, i5, i7, i9, these marketing names. And the i5 is faster than the i3, and the 7 and 9 in turn, which is all well and good, but that's only true within one generation of processor. It gets tricky when you add the next generation. Of course, we're already on, what, 13, I think? So while these partial relations hold, the total ordering is an enormous mess. It's something like this, maybe, and that's just for Intel. It doesn't include AMD. And this becomes a problem in the OSPool because it's hard for us to say, based on the names, which one is faster than the other. And this is mainly because, Moore's law, as we all know, is kind of flattened off the the free performance that we get with just clock speeds. And instead, Intel has been trying to increase performance by adding new instructions. Here's a list of some of the instructions, the code name and the year they landed. And this has really gotten out of control. The number of instructions Intel and AMD is adding is averaging something like 2 instructions per week, sustained over the last 20 years. So these things are kind of getting out of the way. And if we went, and this isn't even a complete list, but you can see sort of the things that are being added. And if you pay attention here to the Westmere with an AES, that will play a place in a little bit. Now, what are we supposed to do with this panoply of different machines that all implement different subsets or supersets of their instruction? Well, the hard way is what the GNU C library does or OpenSSL does, where at runtime, they figure out exactly what machine they're on and exactly what instructions they have. And they switch to different handwritten code that takes advantage of this. And they do that because for some cases, these new instructions can give you a 2 or 3 times, even higher improvement in performance. And that's worth it to them, but only for these places that have so much usage that they can put all the engineering into doing this. And in fact, if you looked at the OSPool, here are the number of cores that we have by the core code name. I would say this graph has a lot of data, but not much information. What are we supposed to do with this? I don't know. And of course, this is a problem because if you build your job that uses instructions your machine doesn't have, it crashes with SIG-IL. I don't know where Christina is, but every couple of months she comes to me with an incomprehensible error message, and that's what this is, and we don't know what to tell people. And of course, the other side can be a problem too, even if it's a decrease in performance. And about a couple years ago, Florian Weimer from Red Hat proposed a solution to this because Red Hat has the same problem, maybe even in spades. They don't want to build a different version of Red Hat for each of these 50 different architectures, but they don't want to be stuck on the least common denominator either. And they can't afford to do this expensive engineering to detect and switch for each of 50 different architectures. And amazingly, everyone came on board quickly. And the solution was very, very straightforward. For all these 50, 60, dozens of different microarchitecture types, they bucket them into 4 different levels. And they called them Miraboledict 2, 1, 2, 3, and 4. And this name is even generative. I don't know what the next generation is going to be. Bet you it's going to be 5. Won't hold them to that. But it does have this generative quality that I like in naming. And more importantly, they put them in a strict hierarchy, which the machines don't necessarily have by generation or by time. That is to say that anything compiled for V1 will run everywhere. Anything compiled for V2 will not necessarily run at V1, but will run on any subsequently higher microarchitecture. So this is fantastic. And the GCC and Quang people came on board super quick. And now you can do GCC dash machine architecture equals the string. Notice the dash, and you will get a binary compiled that will use the instructions defined in that bucket. And this is fantastic. A little bit of downside is once you've done that, the file command can't tell you what exact microarchitecture it was compiled for. If anyone knows a compiler engineer, or knows anyone if anyone knows anyone that has control over the ELF headers, love to have this. So in this release, we added support for the microarchitecture that the Condor startd automatically detects and advertises what microarch is running on. So for example, this is an output from HTC23, which means that if you want to say what are the microarchitectures that are V2 or greater, you could do a constraint expression like this. Notice the quoting. And in your submit file, you could do something like this to say this job needs V2 or strictly greater than V2, which I think is great. And then if we look at the microarchitecture in this pool, we get this graph, which I think doesn't just have data, but it has information. We see that only 1% of the cores in the OSPool, I'm queried, are V1. So if we wanted to optimize our jobs, we didn't need V1, we wouldn't lose too much. We see that only 7% are v4, so probably tuning for v4 today or yesterday when I ran this is not worthwhile. So I think this is very powerful and something that we should all pay attention to. Now, in 9.0 or 10.0 of Condor, we changed Condor to automatically and by default use AES encryption on all of our connections. Why did we do this? Well, we like security. I don't know where Josh is, but also because we were promised that it would be zero overhead. Why is it zero overhead? Because in that 2011 architecture, we got the AES acceleration instructions. And so AES were free. Now, having been bit by this before, we measured this, and indeed, the encryption was free. Voila, as my French friend Frank likes to say. Unfortunately, we made the mistake of using a bad name. I mean, we got bit by the super weakness of poor naming. We said this is free on sufficiently modern CPUs without really putting a fine point on that. And it turns out that the AES instructions showed up in the V2 microarchitecture. And our submit point at the time was running V1. And it turns out in that case, it's not free. And we had to struggle to redeploy our submit machine, our AP, on a V2 architecture. And again, I think this shows the problem of poor naming. We said with hand-wavy, sufficiently modern CPU, where we should have said a microarchitecture of V2 or higher, a very specific, a very more powerful name. In the future, would sure like to be able to automatically detect what microarch some random binary has been compiled for. So if you know someone who knows something with the elf header, would love that. Red Hat is going to start to distribute microarchitecture specific packages and binaries. Maybe that's something we should be doing. I don't know. So those are my future wish list items. So to recap, names have power. Let's be really careful when we pick our names. And I think that in the same way that Newton didn't invent the calculus, nor did Leibniz, they discovered it. We don't invent new names. We discovered existing ones. So let's be very careful to discover good names and names that have power. And on the microarchitecture front, please learn the microarchitecture. You can count to 4, it's not too hard. Please, I beg of you, use the microarchitecture. So you all have pools out there. When you describe your pools, please don't say, I have a pool of Haswell machines with 64 cores and 128 gigabytes of cache and positration and turbochargers and racing stripes. And well, you can say all that, but also say, my pool has all microarch v3 or higher. That will be a very useful name. And level your sorcery up a level. Don't just use these microarchitecture names. Teach them. Like the motto of the surgeon, see one, do one, teach one. Teach other people to use these names. Don't just use them, but teach them and teach them the value. Because I think that if we invest in good naming like this, we're all better off. So I think that's my time. Time for a quick question or two, and thank you very much.